Alright, sure. So namhlanje sizokwenza uNewton's so focus kakhulu kuNewton's second law. Ngifuna sikwazi ukuthi siphendule kakhulukazi lama questions lawa ekuthiwa calculate tension khona. Uthola ukuthi kumele uqale ubale acceleration. Then once uthola acceleration usuyakwazi ukuthi ubale tension for 7 marks. Okay? But sodlula ku first law sibone ukuthi wona siwapply njani first law and then we continue with the second law of which so focus kakhulu ku second law. Okay, so uthini uNewton's first law? I-law le abantu abayaziyo kodwa abanokuyiphambanisa ngenxa ama details amancane. Okay, so first law uthi a body will remain at its state of rest. So an object will remain in its state of rest. Let's use a body will remain at its state of rest. Ikhona ke lesilokhuzana esikeja khona kakhulu simane sithi a body will remain at its state of rest unless a non-resultant force acts on it. But ithini yona ilo? Ithi or the body will continue to move at constant velocity, or motion at constant velocity unless a resultant, a non-zero resultant force act on it. When siyichazeke le law ukuthi ithini le law. Okay, so a body will remain at its state of rest or motion at constant velocity. Ngifuna highlight lo part constant part abantu abangayinaki. It will continue to move. The body will continue to move at constant velocity. Okusho ukuthini? I-object emile if inganakuphazamiseka izohlala emile. This is our object. This object is stationary. So the object is stationary. Izohlala injani? Is stationary. Unless kuba khona i-force eyipushayo isusa la noma idonsayo isusa la ime khona. Okay. Or umihamba izoqhubeka ihambe nge-constant velocity. Asibuyele ku-constant velocity. Mesikhuluma nge-velocity sikhuluma nge-speed. Okay. Constant velocity sithini? I-change in velocity over a period of time. Yini leyo nto? Change in velocity per second. Yini leyo? I-acceleration. Acceleration is the rate at which speed is changing, or it is the rate of change in velocity. Okay, okusho ukuthi sithini? I-velocity final uma ifana ne-velocity initial for a period of time, kusho ukuthi lapho i-acceleration izokuba u-0. So u-first law usho njalo uthi acceleration is u-0 meters per second. I-acceleration u-0 or per second square. Acceleration is u-0 meters per second square because sithini? The velocity final and the velocity initial will not change uma le object ingaphazamisekile. I-velocity izohlala injani? I-constant. So isho njalo ilokhuzana i-question. How do we use the information? Remember sithi F net, the sum of all the forces acting on an object, is always equal to mass times acceleration. So for first law sesiyazi ukuthi acceleration ubani u-0. Therefore sesiyazi ukuthi u-F net ubani? U-F net will be equal to 0 newtons for wonke ama cases la khona kunani khona kune constant velocity, or la khona kune object enjani stationary. First law yileyo nto ekumele si-understande ngawo. So I'll use ama-questions athize, okay, to illustrate le nto ukuthi ibuzwa kanjani le ka-first law ngoba kumele sikwazi ukuthi siyibone. Okay, now ama-questions, ithini lapha equation. In the diagram below, a small object of mass 2 kg is sliding at a constant velocity. It is sliding at a constant velocity. Bayasitshela ukuthi imuva ngespeed esingashintshi, okusho ukuthini akukho shintsho kwi-speed. Change in speed, the rate of change of velocity yini, i-acceleration. Kusho ukuthini i-acceleration uba u0, kusho ukuthini u-f net uba u0. Base bayaqhubeka ke base bathini, base bethi write down the magnitude of the net force acting on the object. Yabo basinike ba u1 mark. Write down the magnitude of the net force. Wena usuyazi ngoba baze ba highlight lapha ya constant velocity. Ngibona constant velocity should I apply Newton's first law. Uthini konje u-F net kalokhuzana ka first law? Uthi u-F net is equal to 0 newtons. Okay, asiphinde sibona another question ukuthi siyibona kanjani lento. Ngifuna si-understand before nje siphendule ama-question ka second law. We need to understand no first law ukuthi uthini sisazowenza ama-question athi into first law. Okay, la question number 10. An 8 kg block P, naile block, is being pulled by a constant force F up a rough inclined plane at an angle of 30 degrees to the horizontal at a constant speed. So as the object moves, it moves up the incline at a constant speed. Sithe thina ngo-constant speed. Sithe constant speed uhamba nani? Uhamba no acceleration obani o0. Buka ukuthi sike siwabone kanjani ama-question. Sebethini ka 10.1.1. State Newton's first law in words. Sivamile ukuthi i-law esi-apply ka 10.1.1 kubiyona leso esizolokhuzana soyi-apply kwi-calculate esi-state ka 10.1.1 kubiyona leso yi-apply lapha kuyini kwi-question ka 10.1.3 kwi-calculation. Okay, so sesiyazi ukuthi la mase sibala i-force we are using u-first law ngoba nakho kuthiwa a constant speed. Okay, let me illustrate ngenye equation. Okay, we have an object. Noma ngeke ngisafundeka yonke into la, but ukuthi when the blocks are stationary. Sithe thina ngo first law, sithe a body will remain at its state of rest. Kusho ukuthi the body will remain stationary, izohlala imile. Okusho ukuthini the body will not have acceleration. Okay, so kusho ukuthi u-net force ubani uyu-0. Bathini ka 6.1. States Newton's first law of motion in weight. Siqeda kulichaza lento ukuthi imvamisa ku-physics into oyi-stateayo iyona lezo yi-apply. So u-first law usuyawuchaza, usuyawustata exactly ngendlela o-appearisha ngayo kuma-guidelines akho. And then to write down the magnitude of the net force for 1 mark. Also, the net force acting on the 10 kg block you 0 because you are applying first law. Every time up here, we use another illustration, and then the two boxes now move to the right at a constant speed. I am mover, they are in motion. Ingakho ngithi kubalekile ukuthi when we state le law, si state correct, singamshiya ukuthi i-object will continue to move at constant velocity, and the body will remain at its state of rest, or the body will continue to move at its state of motion unless an unresultant force acts on it. I want to understand that the body will continue to move at a constant velocity. Sibonile in most questions baqhamuka sebethi constant speed. You need to understand ukuthi izoqhamuka kanjani lento. Batheni lana constant velocity. Ungalindeli ukuthi when the body is at rest first law kuphela. Okay. Ahlule kodwa ku first law yilokho bengifuna kahle kahle sik-highlight kakhulukazi. Asibheke u second law. Uthini u second law? Okay. So second law. Okay. Uthini manje sekuzoba ne net force. When a resultant force acts on an object, sekwenzakaleni manje? Sekune force that is acting on an object, yabo? When a resultant force acts on an object, the object will then accelerate. The object will accelerate at the direction of the force. Okay, lena ngithanda ukuthi understanding. Ngithanda ukuthi understanding. Nayi example. This is imarker. Uma ngiyifaka i-force ngiyiphusha le marker, ngiyiphusha towards the right. Yenza njani? Iyamove towards the right. If nje ngiyiphusha towards the direction of the right ne-object here to the direction of the force. Okay. Okay, the object would accelerate to the direction of the force. I-acceleration enjani? At an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. Okay, so yinto engifuna si-understand futhi kuleya part. Sithi at an acceleration that is directly proportional to the force. Okusho ukuthini? Ukuthi izohamba kangakanani le marker uma ngiyiphusha. Kusho ukuthi ngizoyiphusha ngamandla amangakanani. If ngifaka amandla amancane, imuva kancane nayo iyashesha ukuma. But if ngifaka i-force eningi, kwenzakalani? Imuva kakhulu nayo. Yabo? So if force sikunye ne-acceleration go directly proportional. The higher the force I apply with the object, the more the object move. Okay, but injani i-mass ye-object nelokhuzana. If ngithatha i-mass enkulu ngifaka 10 newtons of force kwi-mass enkulu, izohamba kancane then uma ngifaka 10 newtons of i-force kwi-mass enjani encane. An example ithini? Example ithi if ngifaka u10 newtons of force ku 5 kg block and then I compare the same 10 newtons of force ku 10 kg block, sizobona ukuthi u10 kg block uzohamba kancane than u5 kg block. Ngobani? Ngoba isisindo will prevent ukuthi object yenze njani imove. Okay, so that is second law. But second law yinto ekumele uyithande. Acceleration, ngoba sithe the object will accelerate. Acceleration is not equal to manje equals to 0 meters per second square. Remember sithe ku first law sithe it is always equal to 0, but ku second law sithe it is not equal to 0. Kuyenzeka abe positive or negative. Okay, so sesithini kuma laws izinto ekumele uzi-understande. One, you take ama-laws define exactly as they appear kuma-guideline, and then try to understand lama laws wethu ukuze uzokwazi ukuthi uwa-apply kuma-questions. We'll deal with u-third law towards the last end of lama video ka-Newtons. Okay, sibuye ke sibheke la. Okay, we'll use this question. Ithanda ukuthi ihlukane ama-scenarios kulama question athanda ukuthi ahlukane. Okay, we will find ukuthi there are scenarios mhlawumbe esingawabuka kanje. We have ama-scenario la khona i-object ikwi-flat surface esizoqala ngayo so that we can understand ama-forces acting on an object. Okay, siphinde sibe ne-object la khona ikwi-incline. Okay, enye sophinde sithi siyibheke le scenario, but okwamanje we are focusing ku-horizontal surface, ku-horizontal, and then solandela ngawo ubani u-inclined surface. Okay, take note, this one is horizontal and lo njani u-incline. Okay, asike sibuke i-question with horizontal surface. Okay, bathi lana a diagram below shows a 3 kg block connected to a 1 kg block by a light insensible string. A constant horizontal force of 20 newtons pulls the system along a rough horizontal surface. Okay, so we have lama object wethu on a rough horizontal surface. Okusho ukuthi la there is kulama object wethu kunani kune friction, as a mover kune friction. I-friction is nothing but ukhukhuluza, yahukhuluza, they are not sliding, ayahukhuluza. Okay, so the frictional force between the P block between the blocks P and Q and the surface is 2 newtons and 1 newton respectively. P, which is 3 kg, has 2 newtons of friction, and then Q, which is 1 kg, has 1 newtons of friction. Equation yokuqala state in words Newton's second law of motion. For 2 marks, sithemela ukwazi ukuthi wenze njani uyi-state i-law, kumele ukwazi ukuthi uyi-state. When a resultant force acts on an object, the object will accelerate at the direction of the force at an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. Sithe njalo kuboxapha ukuthi once kwathiwa i-state kusho ukuthi you are going to apply. And mesibheka kule question, we do not have a statement esisitshela ukuthi it move, the blocks move at a constant speed. Okay, so sebethi draw a labeled force diagram. Okay, lathina sowenza a free body diagram because I want to show wonke ama forces, because I want to make a point. Okay, okay, so ka 2.2 kuthiwa sidwebe i-free body diagram, so we'll draw wethu ama free body diagram. Okay, for a 3 kg block, sinani ku 3 kg block, bukisisa, we have this force esibiza ngani, esibiza nge-applied force, sibe nani, sibe ne-tension, sikunye nani this side, ne-friction. Okay, so forces that are acting horizontally. Ngiyazama ukulenza i-dot libe likhulu. Sithe sine force esizoyibiza ngo-force applied acting horizontally. Sibe ne-force ka-friction esizoyibiza ngo-FK frictional force. Sizoba ne-force kumele kumane ngibhale uthi nje force ka-tension. This is tension, okay? And then sibe no-normal force the force that the surface exerts on the object, okay? That is perpendicular to the surface, okay? Buka lama forces lawo sithi lama forces they act parallel to the surface. If ngathiwa ngiyayidweba i-surface, okay, lama forces lawa esiya horizontal, they act parallel to the surface, okay? Note-ke iyona into engifuna siyi-understand, for wonke lama forces esithi they are parallel forces, for parallel forces we'll have F net equals to MA, where A is not equals to 0. For wonke lama forces that are acting parallel to the surface, this is your surface. For illustration, this is your surface. And lama forces memwabuka into parallel. Lezi zinto sithi zinjani zi-parallel ngobani? Because zifacene, so this is parallel to this, okay? So lama forces, they are parallel to the surface, and the acceleration yakhona izoba njani? Izoba greater than u0, ngoba kuyashiwo la ukuthi the system izoqala yenze njani manje? Imove to the direction of i-force, izomove horizontally. Khumbula sitheni ukuthi ulokhuzana when a resultant force acts on an object, the object will accelerate to the direction of the force. The force is pulling the system yethu to the right, so the system will move to the right. Okay, so definitely there will be sizoba ne acceleration. Okay, but for forces that are acting perpendicular to the surface, forces that are acting perpendicular to the surface, for perpendicular forces, we'll have F net always equals to 0 newtons, because there is no acceleration upwards and downwards. There's no acceleration upwards and downwards. Remember, acceleration yenzeka njani? To the direction of the force. So now force applied here to the direction of the force. Okay. Yiyo into engifuna si notice kakhulu. Those that are parallel to the surface, they have the acceleration, in this case, that is greater than 0. But those that are perpendicular to the surface, ngaso sonke isikhathi acceleration yakhona ubani u0, u-F net wakhona ubani u0. So that is how we apply le lokhuzana le understanding. Noma that is how we apply Newton's second law. Into ekumele si understand, it is ama forces. Okay, angiphinde ngichaze le. Ngaso sonke isikhathi when we are dealing with F nets, we can't use F net wawo wonke ama forces. We only check ama forces with sikhuluma ngamaphi. Mhlambe besifuna ukubala for example, la sengikhohle ukubhala uFG or wait. Mhlambe besifuna ukubala normal force. So normal force u-acta njani? U-acta perpendicular to the surface. So F net sithatha F net ama forces anjani? A-acta perpendicular to the surface only. Sesizothi F net ulingana noba F net ulingana no Fn, okay, let's take direction of upwards as positive, so this normal force is positive, so i-weight u-Fg yena uzoba njani, uzoba negative, which is equal to 0. That is why sithi u-normal force in this case ubani ulingene no-Fg, and this is how we calculate u-normal force. Okay, in this question asikaphendula ama-question, I'm trying ukuthi lento si-explain kusayimanje. Okay, let's check for 1 kg block. So for 1 kg block, let me have a diagram la. For 1 kg block, sitheni indaba ye-tension. Let me use benzalomsizi because indaba ye-tension ilula kakhulu. I-tension akusiyona into ezolebele isinika isiphathisane ekhanda. Womane udwebe kanje kube ngathi uyanqamula phakathi nendawo i-tension. Kusho ukuthi le string, it is pulling the object to this direction. Le string, it is pulling the object to this direction. Ngoba simbona i-tension simbhale kanjani in this case. Yabo tension simtheni, sithe uyimisa to the left because now this direction iyapi to the left. So mase sibhala for 1 kg block sesobheka le iyapi iya to the right. So now you get ilokhuzana yakhona i-free body diagram ka 1 kg block. I-dot uzama ukuthi njalo lenze libe likhulu. Okay, we have normal force. Sichazele ukuthi why sithi kwi-horizontal surface u-Fn no-Fg bayabhalansana. Okay, sibe no-Ft ukuze uzobhaleka kahle u-tension wethu, and then we have frictional force. We have friction. Okay, so this is a free body diagram here too. Again, we have perpendicular forces. If unaga, we have perpendicular forces. Okay, we have sum of perpendicular forces as said as long as F net for perpendicular forces will always be equal to bani, will always be equal to 0. But horizontal or parallel forces, so F net is not equal to 0 because there is an acceleration. Okay, let's try to answer the questions so that kuzobonakala ukuthi yabala kanjani le. Okay, 2.3 uthini 2.3 calculates the magnitude of the acceleration for the 3 kg block for 5 marks. Okay, asike siyibukeke sithe for a 3 kg block, these are forces that are acting parallel. So if we acceleration, the object will accelerate to the right hand. The object is say right and move to the direction of the force. So we are going to use parallel forces. Says 2.3. Okay, so this is F net is equal to MA njalo siqala lapho. So F net imaphi forces that are parallel. Let's pick a direction of motion ke asimane sibambe kanjalo njalo direction of motion asiyenze ibe positive. Direction of motion must be positive. So to the right is positive. Now the force applied, we are to the right, so to bani ke FA minus FK minus tension is equal to MA. Okay, siyamazi force that is being applied. Simtsheliwe force applied ku 3 kg block. Okay, asakubhalanga ukuthi sidila noba 3 kg block. Please make sure with the statement you asibhala before ulokhuzana uphendule. for 3 kg blocks, so ngibuka ama forces la kuphela. Okay, so force applied is 20 newtons. Sengiyabuya ngizothi 20 newtons. For 3 kg block, sitsheliwe ukuthi P has 2 newtons of frictional force. So sesithi minus 2 minus T is equal to the mass of an object is 3 kg. So 3 acceleration asingakayazi. Okay, uma solver 20 minus 2 would be 18. Okay, start to 3 let's ngala, it's minus 3a equals to T. So this we'll call equation 1. Okay, and then we move to for 1 kg block. Okay, so for a 1 kg block, sithe now 1 kg block, we have a friction emphasis balele yona ukuthi ubani 1 newtons of force. Now our forces that are acting on a 1 kg block, we have tension and then we have any friction. Okay, so direction of motion again, let's make direction of motion as positive. Ungizwe kahle. Once such a direction of motion is positive for block P, now block Q, the direction of motion must be positive. Asikwazi ukuthi iphikisane lento. Direction of motion, the direction of motion for block P uyafana no direction of motion for block bani, for block Q. Moko wampike positive, you making a positive. So sesithini manje ke tension, because i direction lapha ubani you to the right. The tension you to the right, so to the right is positive. A friction you to the left. So tension minus friction is equal to MA. Okay, we forgot to write F net is equal to MA, which is fine. And then tension asiyazi, but friction siyazi ukuthi U1, and then the block is 1 kg, so this is 1A. So tension ilingana bani no A plus 1. This is equation 2. Okay, so ithi manje lento, equation 1 is equal to T is equal to 18 minus 3a. Equation 2, T is equal to A minus A plus 1. Kusho ukuthi singakwazi kwa equate ama equation wo2, thathe uT, uthathe le equation we substitute lapha. So 18 minus 3a is equal to A plus 1. Then we solve imath. Asathe lo simulating ngale. Okay, no. Asathe lo simulating ngale. So this is minus 4a. 18 momisa ngale. This would be minus 17. And then the acceleration is over ubani. If city 17 divided by 4, because negative no negative we are cancelana, so we'll have an acceleration ka 4.25 kasonke isikhathi awahambe nama SI units, meters per second squared. Okay, so this is your acceleration for ubani ke, for 5 Mach. Okay, so sesiyiphendula kanjani indaba ye tension. Remember question is between 2.3.2. Hence determine the magnitude of the tension in the string for 2 marks, the magnitude of the tension. Okay, how do you go about answering the question? 2.3.2. You know which from above, you know that uT uyalingana no A plus 1 from equation 2. uT uyalingana no A plus 1 from this equation. But acceleration ubani? EU 4.25 plus 1, that will be 5.25 newtons. So this is how we calculate lento tension, and then this is how we get to 2 marks. Okay, so into engiyibona ibaluleke kunayo yonke, 1, it is your understanding kabani yama forces akho ukuthi when we have forces that are always parallel to the surface. We have forces that are always perpendicular to the surface. Lawa perpendicular to the surface ngaso sonke isikhathi, even uma sekune incline, la perpendicular to the surface ayikho i-acceleration, u-F net ubani uyu-0. But for these forces anjani wona are parallel to the surface, you always calculate in the acceleration, because it said the object will accelerate to the direction of e force. Okay, ngoqala lokho. Okwesibili balulekile ukuthi ukwazi ukuthi ukwenze, it is to pick the direction of motion. Once what is to the right is positive, kusho ukuthi wonke ke ama diagram way 2 to the right is positive. Kusho ukuthi la I will have positive, then this side I will have negative. Kusho ukuthi nangala I will have positive, and then this side is negative. So okwesibili lokho njani okubalulekile. Okay, number 3, into ebalulekile, when you try to answer a question, try to write a statement esikanje for a 3 kg block, for 3 kg block, for 1 kg block, so that you'll understand ukuthi manje I'm dealing with F net kabani ka 3 kg block. So it then becomes easy ukuthi ngobheka every body diagram ka 3 kg up until ngiqede la sengobheka abani eka 1 kg block. So that is how we answer. I don't want to make le video ibe yinde. Again, into sesizoyenza manje, we'll do another question. But ukuyenza lento mhlawumbe ithanda uqinaqini, will change ilokhuzana i-diagram yethu. Yes, it will continue to be horizontal, but we'll add a force manje ukuthi i-force ayibe njani manje, ayibe at an angle, i-incline soyenza ngaseqineni. So wenze i-force manje ukuthi i-force ingabe i-force esiyiphula to the right, siyiphule at an angle ethize. Okay, so these are the questions esizowaphendula in the next few videos. We have a question ethanda ukuthi ibuye kanje. I'm not saying exactly this question. Okay, so this is a question where my objects I2, they are at a horizontal surface. Kodwa, the force that is acting on a 1.5 kg block, it is at an angle. Again, as we have an object, a 2 kg block, and with horizontal surface. But the angle that is pulling the object to the right hand, it's at an angle of 20 degrees. So you need to understand Lama questions at Abelanje. So in the next 3 or 2 videos, we'll be doing exactly Lama question before we move Kuma questions and at our inclined surface.